Hello, I'm Scott Turner, and I'm Director of Science Programs at the National Association of Scholars. And this is the Week in Science for the 29th of May, 2025. In today's episode, we take a deep dive into a new shiny object in the ongoing drama of the Trump administration's attack on science. Everyone's talking about it. We're driving hordes of promising scientists overseas as they flee the Trump apocalypse. Well, we'll take a look at that. We also bring in some real science about our evolutionary friends and cousins, the great apes. Okay, let's jump in. Science magazine was comparatively quiet this week about the Trump assault, attack, war, whatever you want to call it, on science. For what it's worth, I prefer to call it a realignment, but that's just me. Back to the topic. This week's shiny object is the science brain drain that the U.S. is about to suffer as cuts in science funding drive promising researchers overseas as they flee for greener pastures. Stories about the impending brain drain showed up in several publications last week. The clear implication is that we, the United States, are shooting ourselves in the foot and ceding scientific leadership to overseas. We're about to experience a Trump-caused brain drain. Foolish MAGA. Here's one example. The University of Hong Kong and other Hong Kong universities are trolling for students to leave Harvard and come to China to study. This comes in the wake of a crackdown on abuse of student visas. Then there's this article, also from Nature magazine, which provides a little vignette of 5 U.S.-based researchers telling Nature why they're exploring career opportunities overseas. I guess they just don't think they're appreciated anymore, as if appreciation can be bought. So they're going to Europe, which I guess they think will appreciate them more. A Portuguese scientist living in the U.S. worries that Europe won't be ready to welcome the exodus and is missing a golden opportunity to become the world leader in science if Europe isn't ready to receive them. Not to worry, though. The European Union is stepping up with a host of programs to draw disaffected American scientists to their borders. And, just to be helpful, Nature magazine provides a handy guide to scientists who are looking to move overseas. And in case we still don't get the message, The Economist magazine weighs in to warn America that we are doing something stupid again. I'll be coming back to The Economist shortly. So that's the conventional wisdom everyone seems to be pushing this week. Trump is plunging America into a scientific dark night by driving its best and brightest out of the country. And the best and brightest seem apparently eager to leave. You know, like Cher. Well, here's a pro tip. Don't be Cher. To help you not be Cher, some perspective is in order. The long-term trend for science funding in the United States since 1950 has been exponentially rising spending, with a doubling time of about 7 years. The Trump budget cuts being proposed are roughly on the order of about 50%, although the actual numbers will differ from agency to agency, and in the end, they'll depend upon congressional appropriations. But back to that 50% reduction. A 50% cut will return funding to the levels of just 7 years ago, that is, 2018. And 2018 was hardly a dark age for science. Returning to 2018 levels of spending will not be devastating for science or scientists. Now, this is not to say there won't be challenges and risks ahead. Funding uncertainty is just a feature of the science ecosystem, though, and science has always been a risky business. I've been there, we've all been there, and this is just the latest episode of funding uncertainty. But that election mandate was pretty clear, and those cuts are coming. Best just to stick it out. But what about those blandishments from foreign countries and universities? The generous funding, the open arms. Look at the fine print. The grass is not always greener, and sometimes it's not even grass. Take those European initiatives to attract U.S. scientists to Europe. They might seem generous, but look again. Norway's Research Council will kick in $9.5 million. That'll go far. The Danish Chamber of Commerce wants to bring in 200 U.S. scientists. Well, Denmark sounds nice, but no details on how it's to be paid for, though. Show me the money, then maybe we'll talk. The University of Montreal will kick in $18 million. Well, it does beat Norway. And so on. The biggest initiatives are coming from the European Research Council's Choose Europe for Science initiative and Horizon Europe, with annual expenditures of about 90 billion euros. And that's real money. Choose Europe for Science wants to spend about $250 million of that attracting U.S. scientists. That sounds good, but again, some perspective is in order. This is about 0.5% of the expected U.S. science cuts of $50 billion. There's also some subtle international economics at work here. That article in The Economist that was warning America that it was in danger of losing all of its scientists to foreign countries was part of a collection of 5 articles intended to show us the folly of our ways. One of the articles made an interesting counterpoint, which I think was inadvertent on their part. The article argues that federal spending on science constitutes a substantial implicit subsidy for other countries. This is because the United States spends a disproportionate amount on science compared to other countries. While the U.S. accounts for about 4% of the world's population, it also accounts for about 1/3 of the global spending on research and development. American universities also attract a disproportionate number of foreign students. While foreign students may pay tuition sticker price, they also benefit from that substantial science spending subsidy. That's because when they graduate, they go back to their home countries with new skills and new technologies, courtesy of that implicit subsidy. The most significant subsidy, of course, is for national defense. The NATO countries, for example, have long been able to spend relatively little of their gross domestic products on national defense, in part because of the disproportionately high American defense spending. This means that the NATO countries have been able to spend generously on other things, like supporting a generous welfare state, and money they can spend on research and development. Well, that's all changing. As the NATO countries are beginning to spend more on their national defense, all non-defense spending is going to be squeezed. So any American scientist looking at these glittering offers being dangled in front of them by European countries needs to be aware that European spending on research is going to be squeezed as well. And that may take the shine off those glittering offers being dangled in front of disaffected American scientists. I have some experience being an American scientist working in foreign countries, and for what it's worth, here are my 2 cents. As long as you're bringing something into a country's research program, and by something I mean more than just glorious you'll be welcome with open arms, camaraderie, and bonhomie. And that's certainly been my experience. As soon as you become a client of the country's research program, though, which you would be if you took one of those offers, you'll find the climate changes. Every country has its own population of aspiring and working scientists to cultivate. Money that your new foreign host spends on supporting you is now going to be money taken away from the citizen scientists of those countries. And as the squeeze tightens, which it's going to, the climate is going to get decidedly chillier. Even in the best of circumstances, the scientific communities in foreign countries are not always sweetness and light. In Germany, for example, the strong hierarchical nature of research groups there seems to be at the heart of a culture of academic bullying. And I'll just say, you don't want to be bullied by Germans. And everything I've just said applies in double spades to anyone contemplating immigrating to China. China has long been buying its way into the American scientific ecosystem. And it's not because China loves us. Some realpolitik is at work here. China is a major geopolitical rival of the United States, and any relationship with China or Chinese universities has to take that into account. It can be pretty risky for American scientists taking support from Chinese authorities. And China, lest we forget, is a totalitarian country. They maintain very tight control over scientific data and publications. You won't find a climate of academic freedom there. And if American scientists are looking for a safe haven to do science in China, they're likely to be disappointed. So I have to say, I don't take all this talk of a scientific brain drain very seriously. For one thing, it rests on an assumption that federal funding is the only avenue for scientific research, and that cutbacks in federal funding will mean the end of scientific opportunities. However, the remarkable thing about the American system is its diversity of funding sources. And more remarkable is the generosity of some of those sources. As we discussed in last week's episode, private funding of science is looking to step in and fill whatever gaps open up as federal science funding changes its priorities. The bottom line? For all its faults, the best place in the world to be a scientist is where the greatest wealth is, and where the culture of freedom is strongest. And, so far anyway, that place is the United States. So buckle in and stay put. And as I said, don't be sure. How about some real science? In the news recently has been a reassessment of a popular science myth, namely that chimpanzees and humans share 99% of their genes. It's one of those popular science tropes that easily rolls off the tongue and that every schoolchild can recite. You know, one of those brainworms that everybody knows, but just because someone else told it to them. But is it true? That's where this paper comes in, by Don-An Yu and 121 co-authors. Yes, 121, that was published recently in Nature magazine. Yu et al. Did a very detailed exploration of the genomes of 6 species of great ape, the family which includes ourselves. The species studied were 2 varieties of chimpanzee, gorillas, 2 varieties of orangutan, and a gibbon. Humans weren't one of the genomes studied, by the way. It's a very technical paper, so I'll just jump right to the conclusion. It's simply not true that chimpanzees and humans share 95% of their genomes. That is, that 1% difference is not true. The similarity is more on the order of 86 to 88%. That is, a 12 to 14% difference. Why the different numbers? Well, there are 2 reasons. First, the scientific basis for the original claim focused on a subset of genes coding for particular proteins. Functional genes, to coin a phrase. Hemoglobin genes, for example. And these were the genes that were very similar between humans and chimpanzees. Chimpanzee hemoglobin genes are very similar to human hemoglobin genes. The authors behind the 1% study, Mary Claire King and A.C. Wilson, concluded that the exceptional differences between humans and chimpanzees had to be attributable to the subset of genes they did not sequence, which they designated regulatory genes. That is, genes that controlled whether other genes would be expressed, whether hemoglobin would be made, for example. The second reason is that the gene sequencing technology available in 1975 was quite limited compared to now. The Yu et al. Study took advantage of advances in gene technology since 1975, which enabled them to focus on the very parts of the genome that King and Wilson were not able to explore. And indeed, it is in these regions of the genome that the big differences occur. It's classic good science. As technology improves, new data overturn old data, and with it, conclusions based on old data. So, what's the importance of this paper besides, getting it right? Well, it turns out that the supposed 1% difference has become part of the ongoing culture war over evolution and what it says about our place in nature. Among the concerns is that the 1% statistic is being used to claim that we're not so different from nature, not even so different from the other primates. Okay, it's a humbling view that we cannot be separated from nature, etc., etc. And I'm all in favor of humility. We are of nature, and we should recognize that. At the same time, the 1% difference undercuts the view that says, well, yes, we might be related to the apes, but we truly are truly different from them. Human exceptionalism, to use the phrase. The broader differences uncovered by Yu et al. Support the human exceptionalism point of view. You see, 12% difference makes humans more exceptional than the 1% difference, or something like that. Which just begs a question. Just how big a difference do you need to be exceptional? I'll come back to this in a moment. But first, I want to ask another question. How do we bring this new knowledge to the public, especially when the 1% trope is embedded so firmly in the public psyche? And this is where museums should come in. The National Museum of Natural History, for example, which is part of the Smithsonian complex of museums, features the 1% relatedness claim prominently in its displays about human evolution. So, the public stand of the Smithsonian, it seems, is against human exceptionalism, right? The human exceptionalism side, for its part, in this case, the Seattle-based Discovery Institute, is demanding that the signage be changed to reflect the new findings. Will they? This is where things begin to get a little dicey. The Discovery Institute is regarded by the polite scientific establishment as something akin to demon spawn. Unfairly, in my view, but there you are. Even so, the Smithsonian museums have themselves not been above reproach. The Smithsonian museums have been the object of several controversies over their signage, which seems to reflect a woke mentality. If you go into the American History Museum, for example, the first thing you learn about Benjamin Franklin is that he had for a short time employed a slave in his print shop and his experiments. Okay, that's interesting to know, but it's hardly the most interesting thing about Benjamin Franklin. The Smithsonian has been embroiled in many controversies over their exhibits reflecting African American history, Native American history, evolution, its planned Latino museum, and others. And the tone presented to the public has, shall we say, been reliably woke. Now, I don't know whether the Natural History Museum will change its signage about human evolution. They've certainly been very, shall we say, open to tailoring their signage toward favored political ideologies. Will it be as willing to adjust its signage when the request comes from the Discovery Institute, even when it's based on pretty solid science? Well, we'll see what happens. Before closing out this segment, I want to go back to that question I posed a few moments ago, namely, How big a genetic difference between chimpanzees and humans do you need for humans to be considered exceptional? The irony here is that the 1975 study by King and Wilson actually started with the assumption that humans indeed were exceptional creatures compared to chimpanzees. They just couldn't explain it on the basis of the functional genes they sequenced. This whole dust-up opens the door to a more fundamental issue in genetics and function. Namely, it elevates the gene, and by this I mean the nucleotide sequence code in DNA, to a position of importance that's far above where, biologically, it should be. In my own view, what the genome says, namely the DNA sequence code that is read by gene sequencing technology, is less important compared to what it does, namely how DNA sequence code translates into the functioning organism. We're still very much in the dark on that question. Chimpanzee DNA and our DNA might say things that are, so far as we know for now, 12 to 14% different, but that doesn't mean that a chimpanzee and a human are 12 to 14% different creatures, even assuming such a thing can be quantified. Okay, that's it for the Week in Science for the 29th of May, 2025. We weren't able to get in enough real science today for my taste. Apologies for that. I try to keep these podcasts under a half hour. Otherwise, it just becomes a commitment. No worry, we'll just work more real science in for the next episode. Remember, these videos are hosted on the National Association of Scholars YouTube page. There's lots of content there, and new content is going up regularly. Subscribe to us, and you'll be kept fully up to speed as new content is posted. We're also working to get these podcasts up onto some streaming platforms, so stay tuned for that. And there's lots more interesting commentary and articles at the National Association of Scholars website at nas.org. If you enjoyed this, please consider joining us as a member. And if you're already a member, thanks for your ongoing support. Until next week.